Okay, picking up where we left off in class, so we measured all these with our protractors, maybe used your vertical angle theorem or linear pair theorem to remember linear pairs will add up to 180, vertical angles are congruent. Now let's look at this in terms of our parallel line angle pairs. So remember what we talked about in class, your alternate interior angles, alternate exterior angles, corresponding angles, same side interior angles. There's also a relationship that you can hopefully very clearly see looking at these numbers. So why don't we take a look at corresponding angles, and what are some corresponding angles we see here? Well, hopefully we're seeing things like angles 1 and angles 5, right? Or here angle 3 and angle 7, right? In this diagram, again, angle 4, angle 8, and angle 2, angle 6. These are just some examples of corresponding angles in our parallel lines. And oops, something you may or may not have noticed. To show that these lines are parallel, what you're looking for this extra arrow here, which I forgot to draw in. So let's draw those in. So this is how you would know in a diagram if we're talking about parallel lines. You'd either be given the word, these lines are parallel, or you'd look for those two little arrows. All right, the same number of arrows represent they're parallel. So if I have 2 here and 1 here, they're not parallel. But if they both have 2, then they are parallel. So quick review on notation there. All right, but going back to those corresponding angles, what did you notice? 1 and 5 here on the left, they're both 117, right? 3 and 7 are also 117. Here, 4 and 8, 101. 2 and 6, 101. So what are we thinking about these corresponding angles? Hopefully you're thinking corresponding angles are congruent, right? So again, not just any old corresponding angles, because our lines don't have to be parallel to make corresponding angles, but corresponding angles in parallel lines, remember that's the sign for parallel, they are congruent. So for example, in our diagram above, we know that angle 1 is congruent to angle 5 in both diagrams because they're both corresponding, right? Or they're a corresponding angle pair. They're in the same position. So if you look at those groups of 4 in this first diagram right here, the 117 is in the upper left. This 5, that 117 is also in the upper left of that group of 4, all right? So corresponding angles are congruent. Let's take a look at some alternate interior angles. Okay, so I deleted those highlights, so we'll look at some alternate interior angles now. So what are some alternate interior angles? Well, hopefully you're seeing things like angles 4 and 6, right? They're on different sides of that transversal, but inside the two parallel lines, or something like angles 3 and 5, right? Alternate interior angles there. What do we notice about them? Here, 4 and 6 that I highlighted, 63 and 63. 3 and 5, 79 and 79. Conveniently, our alternate interior angles are also congruent. And remember, not just any old alternate interior angles. We have to have parallel lines. So alternate interior angles in our parallel lines are congruent. So going back up again, we can look at angles 4 and 5, or excuse me, 4 and 6, and angles 3 and 5 in both diagrams. So for example, angles 3 and 5, right, are congruent. All right. So next, let's look at some alternate exterior angles. So what are some alternate exterior angles that we see here? Okay, well, hopefully, again, I cleared off those highlights so you'll see them a little more clearly now. But hopefully we're seeing, exterior, so outside of the two parallel lines. So things like angles 1 and 7, or angles 2 and 8. So they're outside the parallel lines, but on different sides of the transversal. What do we notice about them? Notice trend? They are congruent. So again, alternate exterior angles in parallel lines are congruent. So for example, again, if we look back up at this diagram, we had things like angles 1 and 7 in both diagrams, or angles 2 and 8. Those are alternate exterior angles and they are made from parallel lines in a transversal. Therefore, they are congruent. So I'm going to say, for example, angle 2 is congruent to angle 8. All right? Finally, same side interior angles. Let's take a look at some same side interior angles and see if this pattern is still holding. Are they going to be congruent? All right, so once again, just clearing off those highlights so you guys can see my diagrams more clearly. But what are some same side interior angles? So I want things that are in between the two parallel lines, but on the same side of the transversal. So something like angles 4 and angle 5, right? Or angle 3 and angle 6. What do we notice about them? Well, they're definitely not the same number. But what happens when I add them together? You guys see how they add up to 180? What does it mean when they add up to 180? It means they are supplementary. So this is the only one that's different. Our same side interior angles in our parallel lines are supplementary. Right? Same side interior angles and parallel lines are supplementary. So going back to look at those diagrams, again, angles 3 and 6 and angles 4 and 5 in both diagrams would be examples of this. So if you're given that diagram or given the information we have same side interior angles, you'd be saying here, for example, angle 3 and angle 6 are supplementary angles, right? And then we can use the definition of supplementary to say that they add up to 180, right? So a couple of things, just a reminder about vocabulary, since we had postulate and theorem. I don't really care if you remember which one goes with which, but just to remember what they mean, postulates are basically things, ideas we take as given, right? Meaning we can't prove it. However, theorems are ideas we can prove. So I could ask you to prove the same side interior angles theorem, prove the alternate exterior angles theorem, or prove the alternate interior angles theorem. So if you see we need to prove these theorems, please don't use the theorem to prove itself. So we're going to do one example right now. How do we prove the alternate interior angles theorem? So the first thing you should cross off your list is using the alternate interior angles, right? We're proving it, so do not, oops, that's not an I, that's a T. Do not use the alternate interior angles theorem. Every year I have students trying to use a theorem to prove itself, and it just doesn't work. It's like saying a computer is a computer or a pencil is a pencil. You need to have more description. You need to have more proof, right? More detail behind it. So use other things you know. Use our very comfortable theorems that we know, like vertical angle theorem, linear pair theorem, definition of supplementary, transitive properties, et cetera. Use that, or even use some other theorems, like the corresponding angles postulate or the alternate exterior angles theorem. The only thing you can't use is the theorem you're trying to prove, all right? So let's take a look at proving the alternate interior angles theorem. So again, it's up to you what you'd like to do in terms of format, 2-column, flowchart, paragraph, I don't care. Just show me the logic. So I like brainstorming in a flowchart. So I'm going to do this in a flowchart. You guys can, again, rewrite it in whatever sequence you like. So I'm going to go ahead and start with my given. So I know L is parallel to M, right? And this is given. Well, if L is parallel to M, what does that tell me about some of the angles I see here? Well, remember, in the end, my alternate interior angles are angles 2 and 3. So I want to show that angles 2 and 3 are congruent. Okay. But what other angles do I know looking at these two parallel lines? Well, what about angles 1 and 3? What are they? Well, I know angles 1 and 3. If L and M are parallel, I know angle 1 is congruent to angle 3 because of the corresponding angles postulate. Since they're in parallel lines, they're in the corresponding angle positions, they have to be congruent, right? So now I've got angle 3 in my proof, but how do I bring in angle 2? Well, what other angle relationships do we see here? Well, I see that angle 1 and angle 2, they share a vertex, right? They're on two different sides of two intersecting lines, so they're vertical angles. So what I know from just the diagram, angle 1 is congruent to angle 2 by the vertical angles theorem. All right? And now I have angle 2 in my proof, but I need to put angle 2 and angle 3 together. How do I do that? Well, notice how that angle 1 repeats. This tells me that I can take out angle 1 and replace it with angle 2 or replace it with angle 3 by using my transitive property, or you can call it substitution. So I need to use these two pieces of information to put angle 2 and angle 3 together. So angle 2 is congruent to angle 3 by your transitive property of congruence. And I'm done. So again, notice I didn't use alternate interior angles anywhere in my proof, but I can use anything else. All right? Let me know if you have questions on that.